Welcome to all my young friends who are studying in intermediate and they are watching this video. Welcome to this series of calculus made easy. As we had already indicated in our first video, that is introductory part, that we are going to discuss certain topics which are very important before we start the actual topic of calculus. Hence, we discuss in two videos intervals and neighborhoods, relations and functions, which are very much used in calculus. And today also we have come up with another topic which is extremely important for calculus and also to the students who are preparing for competitive exams like IIT-JEE and even state level entrance exams, because these are the topics which are favorite topics of examiners, and lots of questions are asked on every year where concepts of these uh, things are involved, that is mod, greatest integer, and fractional part functions. These are certain definitions and they are extremely important. So please listen carefully, and I can assure you that at the end of this video the topics are going to be clear and you can further master them by doing more and more questions. So let's start with the first definition, which is mod. In fact, mod is a short form. The actual name is modulus. So it is denoted by these two vertical lines like this. This is the way of denoting mod. Mod is always positive. This is the thing which you should remember about mod. So what do we mean by that? Let me give you a very interesting example so that it's easy for you to remember this definition. Suppose this is a machine and the name of this machine is mod. If you put positivity into that, because this is the icon which we consider generally positive, so if you put this positivity into this machine, the output is going to be definitely positive. As we have said that mod is always positive. Even if you put negativity, because this icon is considered to be a bit negative, it's a gloomy face or a sad face. Even if you put this into this machine, the output will be positive. So no matter whatever you put into this machine, the output is always going to be positive. That is an interesting definition of mod. But now let's go to mathematical definition. What do we mean by mod in mathematical terms? Mod is defined as absolute value of a number irrespective of the number being positive or negative. Whether it is positive or negative, it is the absolute value, that means a positive. For example, if we have 8, the mod is 8. If we have 3.45, the mod is 3.45, because both these numbers are positive. Now, suppose we have minus 3, the mod of minus 3 will be 3. We have mod of 18, minus 18, it will be 18. So here the number is minus 3 and mod is 3. Here the number is minus 18 and mod is 18. So what we have done to minus 3, that it has become plus 3. Actually, we multiplied minus 3 by minus, then it becomes plus 3. Here the number was minus 18 and we multiplied it by minus so that it became 18. That means if the number is negative, we have to multiply it by minus sign so that it becomes positive. If the number is positive, it will be written as it is. Now, for example, if we have a function fx is equal to mod x, we can also write y is equal to mod x. Now, how do we define this function? We have already said that mod is positive, always positive. Now, if this number inside mod is positive, then mod x is equal to x. It will be written as it is. But if this is less than 0, that means negative, then mod x is equal to, we have to multiply it by a minus sign, that is minus x. So this is the way we write it. Now let us, depict this on a number line, which will again clarify it and make it more clear. For example, this is the number line. We have 0. This side we have plus infinity, and this side we have minus infinity. Now, if x is in this region, that is, it is positive. So this region is depicted by green. So x is greater than or equal to 0, then mod x will be x only. But if x is in this region, that means less than 0, then what will happen? Mod x will become minus x, because x is always already negative in this region. So we have to multiply it by negative so that it becomes positive. I hope this is clear. Let us do one or two more examples. Now we have a function fx is equal to mod x minus 2. So how do we write it? If x minus 2 is positive, that means x is greater than or equal to 2. Then mod x minus 2 will be written as it is, that is x minus 2. So we'll write it like this. But if x minus 2 is negative, that means x is less than 2. Then mod x minus 2 will be written as minus of x minus 2, because we have to multiply it by minus. It will be 2 minus x, like this. So let us again depict this also on a number line. You have 0 and here you have 2. So if x is greater than 2, that means this region in green, then mod x minus 2 will be written as x minus 2 only, because in this region x minus 2 is positive. So it will be written as it is. But if x is less than 2, that means in this region which is depicted by red, then mod x minus 2 is 2 minus x, because suppose x is less than 2, say it is minus 1. So minus 1 minus 2 is equal to minus 3 is negative. So we have to multiply it by a negative number here. So minus x minus 2, which is 2 minus x. Let's take one more example. Fx is equal to x plus 3. Now how do we write it? If x plus 3 is positive, that means x is greater than or equal to minus 3. Then mod x minus plus 3, it will be written as it is, x plus 3. But if x plus 3 is negative, that means x is less than minus 3. Then mod x plus 3 will be written as minus x plus 3, because here we have to multiply it by minus. So this is the way we expand mod x plus 3. Again, let us depict this also on a number line. This is minus 3. So if x is greater than minus 3, shown in with green, then mod x plus 3 will be x plus 3 only. But if it is less, then mod x plus 3 is minus of x plus 3. I hope with these three examples, you are very clear with this idea of mod as to how to expand it. Now, let us see how we define this function, which is mod x plus mod x minus 2. How do we write it? Now, this function is a sum of two functions, that is mod x and mod x minus 2, which again have different definitions in different regions. So let us first of all write their individual definition, and then we will find what is the definition of this fx. Now mod x is equal to, we already discussed x if x is positive, minus x if x is negative, and mod x minus 2 is equal to x minus 2 if x is greater than or equal to 2, 2 minus x if x is less than 2. Now you can see that this function fx, which is the sum of mod x and mod x minus 2, this changes definition at 2 points, one at 0, the other at 2. That means we have to make three regions. First region, x is less than 0. Then fx is equal to mod x plus mod x minus 2, which is equal to, now mod x, when x is less than 0, mod x is minus x, and when x is less than 0, mod x minus 2 is 2 minus x, because when x is less than 0, definitely it will be less than 2. That means plus 2 minus x. That means 2 minus 2x. So we'll write it like this. The other region, x is greater than or equal to 0 and it is less than 2. Then fx is equal to mod x plus mod x minus 2. In this region, you can see the value of mod x will be x, because x is greater than 0. But mod x minus 2 will still be 2 minus x. X will cancel out. This is equal to 2. So this is the second region. And the third region, x is greater than or equal to 2. That means fx. Now, when x is greater than 2, then mod x definitely will be x only, because if x is greater than 2, it will be greater than 0. So fx will be x, and mod x minus 2 also will be x minus 2 plus x minus 2, which is equal to 2x minus 2. So here we have written. Now again, if still there is a doubt, because we have two mods here, some people may think that it is a bit complicated. So let me explain it with the help of again that number line diagram. So you have one function which is mod x, which we already discussed. The number line is like this, and you have another function mod x minus 2, which is depicted on this number line like this. Now here we can divide this into three regions. This is region 1, this is region 2, and this is region 3. In region 1, this is negative and this is also negative. In region 2, this is positive, this is negative. In region 3, both are positive. So in region 1, mod x plus mod x minus 2 will be minus x plus 2 minus x, minus x plus 2 minus x, which is equal to 2 minus 2x. So this is what we have written here. In region 2, mod x will be x, but mod x minus 2 will still be 2 minus x plus 2 minus x, which will be 2. X will cancel out. And this is what we have written here. Similarly, in third region, both are positive. So we'll write mod x as x and mod x minus 2 as x minus 2, which is equal to 2x minus 2. This is what we have written here. I hope that it is absolutely clear now. So let us take one more example involving three mods. Now this is a function where we have involved three mods. So let us divide it into areas where the function will change. Now since there are three mods, 1, 2 and 3, mod x will change at 0, mod x minus 2 will change at 2, and mod x plus 3 will change at minus 3. We have already discussed that. So now let us draw number line diagrams. This is the number line diagram of mod x minus 2 and mod x minus 3. Now here we can easily see that this can be divided into four regions in 1, 2, 3 and 4 regions. In first region, all are negative. This is negative, this is negative, this is also negative. In second region, this is negative, but this is positive. Third region, this is positive, this is still negative, and this is positive. In fourth region, all are positive. So in first region, fx will be mod x, which will be minus x plus 2 minus x plus minus x minus 3, which will be minus 3x minus 1. And this is what we have written here. In second region, fx will be mod x is still minus x, mod 2 x minus 2, which is again 2 minus x, and mod x plus 3. This will be written as x plus 3. So x will cancel out. It will be 5 minus x. In third region, mod x will be x, mod x minus 2 will still be 2 minus x, and mod x plus 3 will be x plus 3. Here these x will get cancelled and this will be equal to x plus 5. So we have written it here. And in the fourth region,